little bit of housekeeping for opening and closing sockets, and yeah, we've pretty much just implemented TCP in JavaScript. Now, what about the attacker, though? What's the attacker going to do? How is he going to open sockets? Well, does anyone at all remember Slurp? My people. Slurp was old school when I first talked about it 6 years ago in 2001. Slurp was NAT in 1995. Back in the day, we didn't have your newfangled broadband. We didn't even have dial-up. No, we had a text connection to a bank of modems connected to Unix servers. And all we had were these so-called shell accounts. There was no ability to route packets. There was no DHCP or getting an IP address. You had text. And then Mozilla happened. And Mozilla rendered JPEGs, which made it really important to be able to get access. So, Slurp would take your text link and would turn it into a way for Mozilla to connect. Awesome. Well, about 6 years ago, I was looking at Slurp, and I'm like, I can use this. I can use this to make my very own special VPN concentrator using SSH. And it was a big, hairy mess, and it involved a protocol by the name of PPTP. PPTP may very well be the world's most hideous protocol. The only competition I know of, well, okay, with the exception of anything in the SCADA world, you guys win, with the possible exception of SMB. Oh, dear God. But no, seriously, if you ever wrap your mind around PPTP, you end up with like TCP over IP over PPP over GRE back over IP with a TCP control channel. It's not good. It does not get tunneled over DNS, but that's just because I wasn't involved. All right. So it turns out you can't even get the most recent versions of Slurp. They disappeared from the web. I had to pull an old hard drive out of storage. What it actually does is, given a stream of packets, it will interpret the stream of packets as connection requests and actually turn them back from packets to connect here, send this data there, close this socket, and so on. It's actually very, very impressive and very useful. So, PopTop was the Linux PPTP daemon. Again, not going to talk about the details of PPTP, but what PopTop will do is it'll take a PPP stream emitted out of Windows, and it will hand it to whatever PPTP daemon you have. In this case, Slurp. Now, normally, Slurp would go ahead and, upon receiving these connection requests, it would create its own sockets. It would run connect, it would run bind, it would do this, it would do that. Now, what if instead of creating its own sockets, what if it gave it, say, to a proxy by the name of Slurpee? So-called Slurpee because Slurpee is the connection between Slurp and IE. The attacker runs applications that use sockets. The sockets get their traffic sent over PPTP to Slurp. Slurp provides the set of streams to the proxy. The proxy tells the browser bucket to open the appropriate sockets. The browser opens the sockets, which themselves provide sockets, and the proxy mediates the traffic between the attacker's sockets and the browser's sockets, and it all just works. No more custom tools in the browser. You want to run Nessus over IE? You got Nessie. You want to run World of Warcraft over IE? You got Wowie. If it's TCP, it'll work. That's what I've been playing with. So, impacts. Well, corporate firewalls are kind of hosed. They're bypassable through lowered browsers, which themselves are really, really accessible via ad networks. There is a special case that needs to be brought up because it doesn't even require Flash. You can do this just from your standard browser. How many of you guys have like Linksys routers at home? Like, little devices that give you wireless, a little web management interface? If you're raising your hand, please change the default password on your home router. Because your home router is accessible from your desktop, and your desktop is accessible from ads on the internet. Ad on the internet bounces off you, goes to your home router, has a bidirectional communication channel. This used to be referred to as the drive-by attack because you used to be able to have image links that would blindly say, yeah, I'd like to download a file from HTTP 192.168.11/ username, admin, password, admin, new DNS server 1234, and it would work. Okay, they fixed this, not by getting rid of default passwords. They fixed this by making it so there needed to be a bidirectional communication between the client and the server. And unfortunately, these DNS rebinding bugs provide a bidirectional communication from the client to the server. It is unpretty. So every browser is now a proxy. There's no botnet necessary to get mad connectivity. If you view an ad, you are now a proxy server. Have a nice day. Every browser can send spam, SMTP, HTTP. Every browser can log into instant messaging networks. Every browser can proxy click fraud. This is, as we say, not a good thing. Google has been losing a lot of money to it. They are going to be losing more. Ideally, you have your big network of IPs you don't pay for ads for. Unfortunately, now every single browser is a route to these attacks. This is not good. There are other things that we can do. Stealth Tor. You know, I like Tor. I know Roger. I help him build stuff. But, you know, I'd like consent to join the Tor network. I would not like to go to websites and suddenly find myself a Tor end node. I can now, unfortunately. We can do some stuff with network neutrality. Oh, peer-to-peer networking. Java gives us UDP, or at least did before they went Nazi and fixed everything. No, I'm serious. I've not seen a breaking change like this in a while. It's called no one was using the functionality at all. To Adobe's credit, they don't have that luxury. UDP sockets are simultaneously clients and servers, so it looked like we could go ahead and have a full peer-to-peer network just between web browsers that came to our website. Sweet. There's a little more. I am not ashamed to admit I was smashed off my ass when I came up with this. On stage at DEF CON 14, TCP/IP drinking game, best thing ever. And I am asked, how would I get around the Great Firewall of China? Now, the answer that I was supposed to provide is, well, I would ignore reset packets, and that way the Great Firewall of China, when it sent me these fake resets, I would ignore them and I would be able to get through. But you see, the question was, how would I get around the Great Firewall of China, which is totally a different answer. I'm like, well, China, well, they send a lot of spam. They receive a lot of spam. By my judgment, that's a high bandwidth, low latency channel. Oh, sweetness and light. All right, we're going to do this in a way that violates every rule of what I know about giving a presentation, which is I'm going to set this up from scratch while attempting to continue my talk. And Elisa, get up here. Get up here. This is some rock star getting the net set up during the talk. Everyone,
actually, I ended up there.
The Network Angels are the shit. They have never let me down in 4 years. All right, so check it out. While I try to set this up, like, well, look, you've got all these servers, you've got all this spam coming in, you got all this spam going out. It's high bandwidth. It's coming in and out at least like every 10 milliseconds, so it's low latency. Oh, yeah. Some of you get where I'm going here. I'm like, let's encapsulate all of our traffic in Viagra. Perfect. Well, so again, I was originally joking, then I'm looking at it and I'm like, you know, I have a browser here, and it's got IP traffic inbound, and it's got spam outbound. Ah, shit, I should actually build that. This is disturbing. Am I supposed to be getting DHCP on this, or really? I'm trying. Renu? I gotta admit. You know, and the great thing is how I have shots immediately available. Oh, sweetness. All right. I have more important things. Hey, I will shoot it when the attack actually works. All right, so check it out. I think I have this mostly set up. All right. This is totally not how you do a demo. Step 1, read Penny Arcade. Ha ha ha. We're going to go ahead, go to our bucket. I am so oh, wait, I know why this is failing. Because I don't trust any of you bastards. No. I would like my DNS to work. There it goes. You know, it's really ironic when DNS doesn't work for me. I actually think it's me getting what I deserve. All right, so check it out here. Do we get a bucket? Oh, we got a bucket. Isn't it beautiful? Design is not my strong suit. All right, so we're going to go ahead. We have our bucket. It's polling. We're going to go to the debug interface of our bucket. I'm going to say, hey, debug interface. Well, let's actually come up with a... This is such a great ad for unnamed vendor. Let's see. hail.ducksparrow.com. This is totally not how you do a demo. Watch. We're going to go over to our debug interface. I'm going to say, hey, debug interface. I would like a connection to, and I'm in fact waiting for the rest of that line to complete, to there, port 22, protocol 6, TCP. And now, as we should see in the background, maybe, this net connection's a little, oh, look at the go! No magic. That was just me switching terminals. We see in the background, it is going to load. That is actually the socket. It is the second level iframe. It's got the JSON that I was referring to. Oh, this net is struggling. It's trying so hard. It wants to succeed. I know it. It is attempting to load, maybe? It's totally not how you do a demo. It is actually attempting to load and not doing too great a job of it. In fact, the link seems to be slow or dying. I will hit refresh once on this, and then I'm going to have to move on. This is the joys of live demos. Wait, maybe? Is it actually going to load the... Actually, that looks good. Maybe. Oh, sweet. We have our socket, we have our connection, and in here, wait for it. It is, in fact, yeah! Like I said, it's like a socket. But it sucks. And it's a full bidirectional socket, 8-bit clean. Actually, it was kind of great when I was writing it. I had this bug where it was almost totally working, except like 1 out of 20 packets would get dropped. Okay, this is TCP. It's not supposed to be able to drop packets. I had a threading bug in a web browser. It turns out, consider this a warning, multiple iframes operate as completely independent interpreters. They are actually different threads. I had a bug where one was sending and the other was receiving, and the two are desynced. I had to re-architect the damn thing.